Tomorrow, 4 human beings will climb inside a capsule on top of the most powerful rocket ever built and leave Earth's orbit for the first time in more than half a century. That's not a headline from a movie, that is actually happening. No humans have traveled beyond Earth's orbit since December 1972, when the last Apollo astronauts left the moon and came home. 52 years of silence, and tomorrow, NASA breaks it. But here's what most people aren't being told: this mission is not just historic. It is dangerous in ways that Apollo never was. The rocket has only flown once before unmanned. The capsule has never carried a crew beyond low Earth orbit, and if something goes wrong 230,000 miles from home, there is no rescue mission. There is no one coming. This is Artemis II, and this is exactly what is going to happen. The Artemis program is NASA's attempt to return humans to the moon for the first time since the Apollo era. But Artemis II is not a moon landing, not yet. It is something arguably more important: a test, a proof of life. 4 astronauts will fly a loop around the moon and return home, proving that the spacecraft, the rocket, and the systems can actually keep human beings alive that far from Earth. If it works, Artemis III will attempt the first crewed moon landing since 1972. If something goes wrong, the timeline for returning to the moon slips back by years, maybe decades. So today, we are going to walk through exactly what Artemis II is, who is on board, what dangers they will face, and why this moment is one of the most significant in the history of human spaceflight. To understand what is happening tomorrow, you need to understand what is actually sitting on that launch pad. The rocket is called the Space Launch System, or SLS. NASA has spent over a decade and roughly $20 billion building it, and by raw numbers, it is the most powerful rocket ever successfully launched in history, more powerful than the Saturn V that carried the Apollo astronauts to the moon. At liftoff, it generates 8.8 million pounds of thrust. To put that in perspective, that is roughly equivalent to 160,000 car engines all firing at the exact same moment. Sitting on top of the SLS is the Orion capsule. This is the crew vehicle. It was designed with a single purpose: keeping human beings alive in deep space. It has advanced life support radiation shielding, a heat shield built to withstand temperatures of 5,000 degrees Fahrenheit on re-entry, hotter than the surface of the sun, and a launch abort system that can physically rip the capsule away from an exploding rocket in under 1 second. Orion flew once before, unmanned, in November 2022. That mission, Artemis I, completed a full lunar orbit and splashed down successfully in the Pacific. But flying hardware with no one on board is a very different test than flying it with 4 lives depending on it. Tomorrow is the real test. 4 astronauts are making this journey, and who they are matters. Reid Wiseman is the mission commander, a veteran Navy test pilot and former ISS commander. Victor Glover is the pilot. He logged nearly 6 months on the International Space Station and is one of the most experienced astronauts currently active. Christina Koch is the mission specialist, holding the record for the longest single spaceflight by a woman. And Jeremy Hansen is a Canadian astronaut, which makes him the first non-American to travel beyond low Earth orbit since the Apollo era. But it gets even more significant than that. Victor Glover will become the first black astronaut ever to travel to deep space. Christina Koch will be the first woman to leave Earth's orbit in history. The Artemis program was designed from the beginning with the goal of putting the first woman and the first person of color on the lunar surface, and this crew is the first step of that journey. These are not symbolic choices made for optics. These are 4 exceptionally qualified people with hundreds of combined hours of spaceflight experience, but the symbolism still matters. Because when this rocket clears the launch tower tomorrow, it will carry a message: deep space exploration belongs to everyone, not just a select few, everyone. Here is exactly what happens over the next 10 days. After liftoff from Kennedy Space Center in Florida, the SLS will send Orion on a trajectory toward the moon. For the first few days, the crew will monitor systems, run tests on Orion's hardware, and adjust to the deep space environment, a radiation environment far more intense than anything inside low Earth orbit. Around day 4, Orion performs its closest approach, a lunar flyby skimming within roughly 6,400 miles of the moon's surface. The crew will see the moon the way no human has seen it since 1972, not as a distant light in the sky, as something that fills the window, a real place right there, close enough that the craters are visible with the naked eye. And in that same moment, they will look behind them, And Earth, the entire planet, everyone who has ever lived, all of human civilization, will appear as a small blue marble floating in black. Then comes the most critical moment of the entire mission, the trans-Earth injection burn. Orion's engine must fire to break away from the moon's gravitational pull and start the journey home. If that burn fails or fires incorrectly, the crew could find themselves in an unplanned trajectory far from Earth, with limited fuel, limited options, and no immediate rescue available. If everything goes right, Orion re-enters Earth's atmosphere at roughly 25,000 miles per hour, faster than a bullet, and splashes down in the Pacific Ocean approximately 10 days after launch. 685,000 miles, 10 days, and humanity will have returned to the vicinity of the moon for the first time in over half a century. But here is what the press releases don't emphasize, because this mission has risks that go beyond mechanical failure, risks that are built into the universe itself. In low Earth orbit, where the International Space Station lives, astronauts are still partially shielded by Earth's magnetic field. That field deflects the most dangerous radiation, solar flare particles, galactic cosmic rays before they can penetrate human tissue. Move beyond that field into deep space and that protection disappears completely. The Artemis II crew will be exposed to radiation levels roughly 700 times higher than what we experience on the surface of Earth. Over 10 days, that dose is within acceptable mission limits, but space weather is unpredictable. A powerful solar flare erupting at the wrong moment could dramatically increase that radiation exposure in a matter of hours. NASA monitors the sun around the clock and has protocols to direct the crew into the most shielded part of the capsule during a flare event, but there is no way to eliminate the risk entirely. You are exposed. Full stop. And then there is the machinery itself. The SLS has launched once. Orion has flown once unmanned. Deep space mission control protocols have never been executed with a live crew. Everything is being stress-tested for the first time with actual human beings on board. That is not pessimism, that is physics. The Apollo astronauts famously estimated their own odds of not returning at roughly 1 in 3. Today's engineering is far more refined, far more reliable, but no one on this crew would tell you the risk is 0. They know it isn't. They got in the rocket anyway. That is what it means to be an explorer. 52 years ago, Gene Cernan stepped off the surface of the moon, climbed back into his lunar module, and became the last human being to stand on another world. Before he left, he said, "We came in peace, and we shall return." Tomorrow, NASA begins to make good on that promise. Artemis II will not land on the moon, but it will prove that we can reach it, that the hardware holds, that the mission is real. And it will carry 4 human beings farther from Earth than any person has traveled since 1972, out into the deep black around the moon and back home. What comes after this, if this mission succeeds, is a moon landing, then a permanent base on the lunar surface, then, eventually, the long journey to Mars. We are standing at the beginning of the second great era of human space exploration. The first era started with a footprint in the dust and a sentence heard around the world. The second era starts tomorrow. Will you be watching?